Namaste. I am Debartha Chatterjee. I am a PhD research scholar in the Department of Mechanical Engineering. I am working in the phase change thermal systems laboratory under Professor Samir Khandekar. So, you know, the water crisis in India is going through the worst phase, and this needs no further introduction. So, the conventional desalination plants, reverse osmosis based, are very energy intensive and are not sustainable for a greener future, and the huge amount of brine disposal that takes place has a huge environmental concern. So now over here you can see in the last decade that a photothermal based interfacial heat localization strategy is being shown as a viable option for solar thermal based portable devices which can generate portable drinking water. In such kind of a system, the vapor generating surface and solar irradiation surface is coupled, and because of that you need sophisticated fabrication methodologies to fabricate these systems, which may not be scaled up and commercially viable. Second disadvantage is that after few hours of operation, the salt accumulation blocks the solar absorbing surface, which reduces the efficiency drastically, and there is no scope of latent heat of condensation that can be recovered to increase the water productivity. So here we propose a thermosyphon integrated heat localization strategy for the first time. Here what we do is decoupling the vapor generating surface from the solar absorbing surface. So now solar absorption can take place outside the house and the vapor generation can take place inside. This has the advantage that you can use commercially available flat plate evaporators or evacuated tubes which are commercially available. This can be incorporated, and you can use commercially available any philic materials like a cotton handkerchief which can be used to generate the vapor. And the third possibility is that you have now the possibility of recovering the latent heat of condensation, which can be reused multiple times to increase the water productivity. So in our case, we have first gone with an open system configuration where we studied the effect of temperature and relative humidity on the vapor generation rate, and also the optimization of the thermosyphon for application for 1 to 4 sun application cases. Here you can see that we have done for 1 sun to 4 sun application cases, and the IR images of the vapor generation surface shows that there is no salt accumulation, and we have done the solar to vapor conversion efficiency is comparable to all the studies which is available in literature for such kind of a systems which requires complex fabrication. And we have done a 7-day trial with simulated solar water, and you can see that the evaporation rate is maintained. So this is day 1 of the fabric material, and this is day 7, and it shows that there is no salt accumulation that has occurred. In the second stage, now we are going from an open system kind of a configuration to a closed system, because to collect water you need the system to be closed, and in such a closed system the heat and mass transport is completely different than an open system, and the gap between the condensing surface and vapor generating surface plays a dominant role. So in this study we show for 2 different temperature gaps and 2 different temperature of the condensing surface on the evaporation rate and collection rate. So we are operating now in this regime, and we show that as the temperature gap is reduced, the vapor resistance is reduced, and you get a much more good evaporation rate. And for lower condensing surface temperature, the condensation coefficient increases and you get a better water collection rate. So in this kind of a setup, our final goal objective is to build a solar thermal based portable drinking water system which generates water, and also it is a zero liquid discharge system, so that we can harness the minerals and salt collected, which can be reused in a rural community, and it can be an income source for them. And this application is only for arid regions in rural sectors. Thank you.